Okay, Unit 2 test review. We're solving absolute values and inequalities that are linear. So we're going to get started on A. All of these are just inequalities without absolute values. So reminder, if these are and or, it's either going to tell you or they're going to look like this. So this is an and problem because it has two inequalities. If it's or, it's always going to tell you. So just a good thing to remember. If you look at A, we have to get all of our x's on one side and all of our numbers without x on the other. I personally like to move my smallest x first. So I'm going to move my 6x. And I get negative 10 is greater than or equal to 3x minus 4. And now I need to get my numbers without x on the other side, so I'm going to move this 4 that's next to my x by doing plus 4, and I get negative 6 is greater than or equal to 3x. So my last step to get my x by itself, well, this is multiplying, and the way we get rid of multiplication is division. And I'm dividing by a positive 3. Remember, the number on top does not tell me to flip my symbol. It's the number on bottom that does. And it's a positive 3, so we don't have to worry about it. So I have x. On that side, I have this symbol, and negative 6 divided by 3 is negative 2. However, I know a lot of times y'all don't like when it's this in this order, so you can flip it. But I want you to realize the alligator mouth still has to be eating the 2. So my symbol flips also. Now, inequalities, remember we always have to write them on a number line and in interval notation. So this is negative 2. It's going to be negative infinity, positive infinity, and remember, left is less, right is greater. So if this is x is less than or equal to negative 2, less than or equal goes to the left, equal to gets a square bracket. And remember, everywhere that's shaded is a solution because it's just, there's no and or. So it goes from negative infinity to negative 2 with a square bracket, and infinity always gets parentheses. Okay, so let's look at B. So this one is an and problem because it has two inequalities. When it has two inequalities, you're going to draw two lines, and what you're solving for x in the middle. Don't ever move the numbers on the outside. You'll move numbers to the outside, but you're not going to move the numbers on the outside. So first things first, I need to get rid of this 10 that doesn't have an x, and it's positive, so minus 10, minus 10, minus 10. If you struggle with negatives, make sure you're using your calculator. Negative 6 minus 10 gives me negative 16. I'm going to bring down my same symbols. These 10s cancel, and I have negative 4x. Bring down my same symbol, and 12 minus 10 is 2. So lastly, I'm going to divide by this negative 4, but when I divide by a negative, I have to flip my symbol. So I'm going to flip both of them. This cancels because I divided everything by a negative, so I had to flip both. Negative 16 divided by negative 4, well, two negatives makes a positive. 16 divided by 4 is 4. And 2 divided by negative 4, if you struggle with simplifying fractions, you can type it in your calculator as alpha y equals enter, 2 over negative 4, and it tells you negative a half. So we get negative 1/2. So now I'm done. I know that this is an and problem. So negative infinity, infinity, and remember, it being an and problem tells us that we want them to overlap. So less is always on the left, so negative a half, positive 4. And the confusing part with these problems that a lot of people struggle with is that first part you have to read backwards. So yes, that's a greater than symbol, but you're reading from letter to number, and the alligator's eating the 4, therefore the 4 is bigger, and the x is less. So x is less than or equal to 4. Less goes to the left. Now, if you follow that rule of which way is the inequality pointing, you can't do that when x is second. See how the number comes first? You can't follow that rule here. So unless you know that it's backwards, so you're doing opposite. Now this side, x is first, So x is greater than or equal to negative a half, or it's pointing to the right. And this is an and problem, so your solution is where they overlap. And it overlaps between a half and 4. These are not part of your solution. So it goes from negative a half all the way to 4. Okay, let's look at C. C is also an and problem because it has two inequalities, sorry. So we're going to draw our lines, and we're solving for x. Well, the nice thing is there's no multiplication, there's only addition. So how do we get rid of this positive 2? We're going to do minus 2 on all sides. And I get x alone. I'm going to bring down my symbols. This one has an equal to, this one doesn't, so be careful. Negative 4 minus 2 is negative 6. 5 minus 2 is 3. And then we're done solving. So we're just going to put it on our number line. This is negative 6. This is 3. Negative infinity, positive infinity. Okay, again, reading it backwards. The alligator is eating the x, so x is bigger than negative 6. Bigger is the same thing as greater, which goes to the right. And it's not equal to, so it gets a parentheses. Here we have x is less than or equal to 3. Less than goes to the left. Equals to gets a square bracket. And it's an and problem, so it's where it overlaps. So this is not a part, this is not a part. And it goes from, with a parentheses, negative 6 all the way to 3, and it stops overlapping. So just remember, the parentheses telling you that negative 6 is not a solution, but everything on its way to negative 6 is a solution. 3 is a solution because it has a square bracket. And everything in between, so 0, 1, 2, 2.5, negative 4, okay, so on and so forth. Everything in there is a solution. Okay, on this one, we're going to move our smallest x, which is this negative 2x, so plus 2x, plus 2x, and I have 10x plus 9 is less than 3, so I'm going to do minus 9, and I get 10x is less than negative 6. Divide by 10, divide by 10, and again I get x is less than, well, negative 6 over 10. So again, if you struggle with simplifying fractions, first off, I know that those are both even numbers, so they're gonna simplify. If you're not sure if they simplify, you can also type them in the calculator. It's the same thing. So it gives me negative 3/5. So x is less than negative 3/5. Less goes to the left. It's not equal to, so it gets a parentheses. And this is alone, so it's everything. Therefore, it is negative infinity all the way to negative 3/5 with a parentheses. Okay, look at the other side. Okay, E has a lot more work than the other ones. We have parentheses, therefore we have to distribute. Now, one thing I want you to remember is PEMDAS. Okay, PEMDAS is your order of operations. Parentheses, okay, well, we can't simplify inside. There are no exponents. Multiply and divide go together. Add and subtract go together. So I do have multiplication because 3 is touching the parentheses. That's multiply. So I have to multiply first. So 3 times x. I'm going to go ahead and bring down this 6 also. It's a negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. It's less than or equal to 3x plus 9. Nothing on that side simplifies. Now I got rid of my multiplication. There isn't a division. Now I add or subtract. So 6 plus 3. So I get negative 3x plus 9 is less than or equal to 3x plus 9. I'm going to move my smallest x, so plus 3x, get 9 is less than or equal to 6x plus 9. minus 9, and I get 0. So I have 0 is less than or equal to 6x. Well, technically, my x is not alone yet, so I've got to divide both sides by 6, but 0 divided by anything is just 0. 0 is less than or equal to x. If I wanted to flip this, the alligator's eating the x, so it would be this. We have 0. Remember, 0 is a number. It's okay to get 0. X is greater than or equal to 0, greater than, equal to, so we have 0 to infinity. Okay, there's multiple ways to do f. Okay, technically, if you want to just divide by negative 6 over 5, will your calculator do that for you? Absolutely. The proper way to get rid of fractions is to multiply by the reciprocal, the flip. Well, if I flip this, I get 5 over 6. So I'm going to multiply both sides by 5 over 6. Negative 5 over 6, sorry. Because we want those negatives to cancel on the left, right? 2 negatives makes a. These 5s cancel, these 6 cancels, and I get x is greater than or equal to, and then can we do the rest in the calculator? Yes, we can. 2 times negative alpha y equals enter, 5 over 6, and I get negative 5 over 3. And then I'm done. So x is greater than or equal to negative 5 over 3. Greater than goes this way, equal to looks like this. So that's positive infinity, so I get negative 5 over 3 to infinity, and there's my solution. Any questions with that? Okay, last one in this section. I know it seems like a lot. Okay, this one is a little different. Okay, but if this is x, what would we say that is? It's a fraction, but what does that represent? Addition, subtraction, multiplication, or division? Division. How do we get rid of divide by 3? Well, we do the opposite, which would be to multiply both sides by 3. That cancels that. We have x is less than or equal to negative 6 times 3, which is just negative 18. These last two were not bad. It's pretty simple. So we have negative 18. X is less than or equal to. And it's everywhere it is. So it's from negative infinity all the way to negative 18 with a square bracket. For which one? Oh, good call. On F, we should have flipped a sign. We multiply both sides by a negative. Thank you. So it's less than or equal to. My bad. See, I do it too. So x flipped is less than or equal to. So it's going to be negative 5 over 3, and it's going to go less than or equal to. So negative infinity to negative 5 over 3. Thank you for catching that. Bless you. Okay, look at number 2. Okay, so number 2 says solve the following inequalities showing work. Write solutions in interval notation. Graph the solutions on a number line. Okay, so this is a bunch of and or problems. So most of them are and because this is and, this is and, this is and this is or. So it's got a mixture of some of the stuff that was up there, but it also has or problems. So this one, remember when you have and in the middle, bless you, and you have both you're going to solve them separately. So divide by 2, divide by 2. I divided by a positive. X is greater than or equal to negative 4 divided by 2 is negative 2. Bring down my and. Plus 1 plus 1. X is less than 3. So now I have both. Remember, you graph them both on the same number line. Which number is smaller? Well, negative 2 is smaller than 3. And this is an and problem, so I want them to overlap. X is greater than or equal to negative 2. X is less than 3, but it's not equal to, so that gets a parentheses. And is where they overlap, which is everywhere in between. So it goes from negative 2, which is included, to 3, which is not included. Okay, look at B. Again, same concept, except this time is or. So we're going to solve both sides. So here we have distribution again. So 2 times x is 2x. 2 times negative 1 is negative 2. Is less than or equal to negative 8. I'm going to add 2 to both sides because I only have x on the left, so I don't want to move the x. And I have 2x is less than or equal to negative 6. Divide by positive 2, so we're not flipping. We get x is less than or equal to negative 3. Bring down that or so I don't forget. And now we're going to do the other side. So I'm going to do minus 5, minus 5. And I have negative x is less than or equal to negative 2. However, now to get rid of that negative x, I have to divide by negative 1. And when I divide by a negative, I have to flip my symbol. And I get positive 2. So x is greater than or equal to positive 2. So this is an or problem where they don't have to overlap. Negative 3 is smaller than positive 2. X is less than or equal to negative 3. Less goes to the left. X is greater than or equal to 2 goes to the right. This was equal to, this was also equal to. So they're both equal to. And remember, or is anywhere you shaded. So here's shaded and here's shaded. Therefore, it goes from negative infinity all the way to negative 3. And then it takes a break. It has a gap. That's where the u goes, in the gap. And it picks back up at 2 and goes all the way to infinity. Another and problem, because they're together, we know it's and. Let me get rid of this 3 first by subtracting. It's a positive 3. I know it's subtracting minus 2p, but it's still positive, so we have to subtract it. And I get 7 minus 3 is 4, is less than or equal to negative 2p, is less than 11 minus 3, I don't know why I can't think of that, is 8. And now I have to divide everything by what's left next to my p, which is a negative. So I need to flip all of my symbols. And I have p alone. 4 divided by negative 2 is negative 2. 8 divided by negative 2 is negative 4. Which number is smaller, negative 2 or negative 4? Remember, when they're negative, it's opposite of what you think. So negative 4, negative 2. So p is less than or equal to, remember, we're reading this backwards. It's eating the 2, so the 2 is bigger. So p is less than or equal to negative 2. Less goes to the left. Equal to gets a square bracket. P is greater than 4, negative 4. No equal to. So parentheses, and it's an and problem. So it's from -4 to -2. Lots of repetition on here. Okay, one more on the front. And then we move to the back. Okay, here it's an AND problem. So I'm going to add 3 to both sides. I get 5x is greater than 10. Divide by 5, divide by 5, x is greater than 2. I'm going to bring down the AND so I don't forget. Plus 6 plus 6. 4x is less than -4. Now remember, I'm dividing by a +4, not a negative. Negative's on top. So I'm not flipping my symbol. I get x is less than -1. So -1 is smaller than 2. This is an AND problem. X is less than -1. X is greater than 2. Neither of them are equal to. Well, if this is an AND problem, we're looking for where they overlap, and neither of these overlap. Therefore, this is no solution. Okay, let's move on to the back. We have another OR problem, and then we're throwing in some absolute values. So here at E, it's an OR problem. Bring down the OR so I don't forget. I have to get rid of the 7 without the letter first, so -7 minus 7. I get -3c is greater than or equal to 1 minus 7 is -6. Now I'm dividing by a -3, which tells me to flip my symbol. So I get c is less than or equal to 2 negatives makes a positive, 6 divided by 3 is 2. Okay, here, -2 minus 2. 5x is greater than or equal to 15. Divide by 5, divide by 5. I get x is greater than or equal to 3. So I have 2 is less than 3, so 2, 3, -infinity, infinity. And the c is less than or equal to 2. And x is greater than or equal to 3. They're both equal to, so they both get square brackets. And this is an OR problem, so it's okay that they don't overlap. So it goes from -infinity all the way to 2 with a square bracket, has a gap, and picks back up at 3 and goes to +infinity. Okay, last AND problem that doesn't have an absolute value. Okay, so I'm going to do -7 minus 7 minus 7. Okay, and I get -8 is less than 4x is less than or equal to 4. Divide everything by 4. I don't have to flip any symbols. 4 divided by 4 is 1. -8 divided by 4 is -2. So this goes from -2 and 1. Remember to read it backwards. It's eating the x, so x is bigger than -2. Bigger goes to the right, and it is not equal to, so it gets a parentheses. X is less than or equal to 1, less than or equal to goes to the left, equal to gets a bracket, and then it's where it's overlapped. So it overlaps from -2 to 1 with a square bracket. Whew. Okay, now we're going to absolute values. So remember, absolute values, you have to make sure your absolute value is alone before you start anything. The nice thing is this one's already alone, so we don't have to worry about it. Always check if it's negative. There is no negative, so we're good to go. We're going to rewrite it exact. And we're going to rewrite it flipped symbol -9. And we're going to solve both. But before I keep going, I need to figure out what symbol I'm using. This is a less than, which tells me it's an and problem. Okay, so +5 + 5, get 2c is less than 9, 14, divide by 2, I get c is less than 7, +5 + 5, 2c is greater than -4, divide by 2, and I get c is greater than -2. So -2 is less than 7. So c is less than 7. Less goes to the left. It's not equal to, so it gets parentheses. c is greater than -2. Greater goes to the right. It's not equal to, so it gets parentheses. And this is and, so it's where it overlaps from -2 to 7, both with parentheses. Okay, H, remember, you have to get your absolute value by itself. Okay, and it's not by itself. So first things first, we need to subtract 3 from both sides, because we have to get rid of that +3 to get my absolute value all alone. So -3, and I get the absolute value of y + 2 is less than or equal to 1. So it's not negative, so we're going to keep going. It is alone now, and we need to pay attention to what sign we have. So this is my less than or equal to, so less than. Remember, that makes it an and problem. That was beautiful handwriting, I know. Okay, so then we're going to rewrite it. So we're going to rewrite it exact without the absolute value bars. Y + 2 is less than or equal to 1. And then we're going to rewrite it y + 2. We're going to flip this symbol, so greater than or equal to, and make it opposite, so -1. And now we're going to solve both. Oh, it is supposed to be -2. Thank you. This is not the first time I've messed up on this. Y'all will see later. -2. My bad. Thank you. Okay, so now we're going to add 2. We get y is less than or equal to 3. Add 2, and I get y is greater than or equal to 1. And then we have to graph it. So this is an and problem, meaning we want them to overlap. So 1 is smaller than 3. And we have y is greater than or equal to 1. Greater goes to the right. Equal to gets a square bracket. And y is less than or equal to 3. Less than goes to the left. Equal to gets a square bracket. And it's and where it overlaps everywhere between 1 and 3. Now I want you to realize 1 is a solution here. And I know that because it's a square bracket. 2 is a solution here because it's inside where it's shaded. 3 is a solution here. 1.5, 2.5, 2.7, okay, all the things in between, including 1 and 3, are solutions. Okay, let's look at I. Again, make sure your absolute value is alone, and on this one it is already alone, so we're good to go. So we're going to rewrite it exact. 5x minus 4 is greater than or equal to 16. And then I'm going to rewrite it 5x minus 4. Flip my symbol, so less than or equal to opposite, so -16. And we're going to solve both. So before I keep going, I want you to realize this symbol is great or, so this is going to be an or problem, yes? Plus 4, 5x is greater than or equal to 20. Divide by 5, and I get x is greater than or equal to 4. Okay, plus 4, 5x is less than or equal to, that gives me negative 12. Divide by 5. Well, if you don't know, you can always try to simplify it in here. Alpha y equals enter, negative 12 over 5. And look, it is as simple as it gets. So x is less than or equal to negative 12 over 5. You could also do negative 12 divide 5. I wouldn't mind if you wrote it or as negative 2.4 because that's a simple decimal, right? So I'm going to squeeze this in here. And negative 2.4 is smaller than positive 4. And I have x is greater than or equal to 4. And x is less than or equal to this. And this is an OR problem. Is it okay that they don't overlap? Yeah, remember, OR is anywhere it's shaded, and you'll probably use the U for union, right? Well, does this have a gap? So that's where your U for union is going to come into play. So it goes to the left forever, negative infinity to negative 2.4. I know I have so much space here. Union, I'm going to kind of come back down here, and I have 4 to infinity. Okay, last one, that's an inequality. Okay, again, we have to get our inequality, our absolute value alone. But I have that 6 in front. Remember, you're never going to put something inside the absolute value bars that wasn't already in there. So now if I could simplify on the inside, that's fine, but this 6 is on the outside. I cannot distribute it in. So what's the opposite of multiplying it in would be dividing both sides by it. So that cancels, and I get the absolute value of 2n minus 1 is greater than or equal to 1. Now my absolute value is alone, and again, this is a great OR problem. So it's going to be an OR problem just like I. So I'm going to rewrite it. 2n minus 1 is greater than or equal to 1. And then I'm going to rewrite it. 2n minus 1 is less than or equal to negative 1. Remember, opposite, opposite. Is 0 a number? Is it okay to get a 0? Yes. 0 is a number. It is. You can have $0. That would suck, but you can. Okay, so plus 1. You can have negative dollars too. Okay, this cancels, and you get 2n is greater than or equal to 1 plus 1 is 2. Divide by 2, and I get n is greater than or equal to 1. Same concept over here. Plus 1. I get 2n is less than or equal to, what's negative 1 plus 1? 0. 0 is okay. Divide by 2, and you get n is less than or equal to, well, if you're unsure, 0 divided by anything is 0. However, if you ever have 2 divided by 0, it'll tell you it's not possible. You cannot divide, 0 is not allowed to be on the bottom. Okay, that would be not a thing. But it's okay on top. Okay, so these are the numbers we have. This is an OR problem. Are we okay if they don't overlap? Yeah. And remember, with absolute values, they shouldn't overlap, and if they do, it's because we didn't notice there was a negative at the beginning. And we just did a bunch of work when we didn't have to. Does that make sense? Okay, so knowing that I have 0, which is less than 1, n is greater than or equal to 1, n is less than or equal to 0. And they're both equal to, so they both get a square bracket. So it goes from negative infinity to 0 with a gap, and then it picks back up at 1 to infinity. Any questions with those? Okay, the rest of them are going to be a little quicker and easier. Okay, so let's look at number 3. A, B, C, D on number 3, it just says write an interval notation from the number line. You don't have to make the number line. The number line's made for you. Yes? But I want you to remember, this is negative infinity, this is positive infinity. Okay? So this graph is shaded which way? What's the farthest left it goes? Well, it goes left forever. See how it's bolded to the left forever? That means it goes from negative infinity all the way till 3 with a parentheses. Here's your answer. Well, this one starts being bolded at negative 1 with a square bracket, and it goes to the right forever, which represents infinity. And remember, infinity always gets a parentheses because you cannot touch infinity. The square bracket represents that's being a solution. Infinity will never be a solution. It just means it goes on forever. Okay, this is going to be an OR problem, okay, because there's a gap. So it goes from negative infinity to negative 2 with this square bracket, and then it has a gap. Remember, the U represents your gap. And it picks back up at negative 1 and goes to the right forever to infinity. Last one, this is an AND problem. Okay, and it starts being bolded at negative 3 with a square bracket and goes all the way to 2 with a parentheses. So like I said, those are our easy ones. We like those. Okay, the next one says we're going to draw the graphs for the given solution. So we're doing the opposite. We're going from this to that. So I'm going to draw my number line for each of these. Okay, it's giving it to me in interval notation, and it's telling me to find it. Well, what does negative infinity to infinity mean? It's just another way of writing all real numbers. Okay, remember how we wrote it both ways? So all real numbers, doesn't that mean the whole number line is shaded? The whole thing. There's no numbers on it, everything's a solution, shade the whole line. Okay, that's all real numbers. Now here, negative 3 is smaller than 2. Negative 3 has a parentheses, 2 has a square bracket, and it's just shaded in between. Here is telling me 9 to positive infinity. Well, 9 can be here, has a square bracket, and it goes to positive infinity, which is to the right forever. And everything that way is a solution. Remember, this is an AND problem also, and this is an OR problem. So it goes from negative infinity to 6 with a, that's an arrow, sorry, with a parentheses. Then it picks back up at 11 with a square bracket and goes to the right forever. So those are your graphs. Any questions with number 4? Not too bad. Okay, the last one, the last couple, is number 5. We're solving inequality equations. We like those. There's no graph, there's no interval notation. It's super simple, solve, put it in fancy brackets, right, or braces. So here, my absolute values alone. So I'm going to rewrite it. 2x equals, freeze. What does it equal? A negative. What do you do when it equals a negative? You stop. Now this is an equation, and on equations, what's your answer whenever it is negative? No solution. Because because remember, absolute values give you a positive number. A positive number will never equal a negative 10. It's not possible. So that's no solution. Okay, B, I need to get my absolute value alone. What do I have with my absolute value? I have that plus 8. How do I get rid of a plus 8? I'm going to subtract 8 from both sides. And I get the absolute value of 3x equals 20 minus 8 is 12. Now my absolute value is by itself. It equals a positive, so we're good to go. We're going to separate. 3x equals 12. And then we're going to rewrite equals to the opposite, so negative 12. And we're going to solve both. Well, 3 times x, the opposite of multiplication is division. And I get x equals 4. Again, divide by 3, and I get x equals negative 4. And remember, we write our answers in the fancy braces, so negative 4, comma 4. Okay, so this one, C, has a 2, but remember, we can't put that 2 in by multiplying, so the opposite would be to divide both sides by 2. And I get the absolute value of 3x minus 9 equals 6. So it equals a positive, so we're ready to solve. We're going to rewrite it. 3x minus 9 equals 6. And 3x minus 9 equals negative 6. And solve both. So add 9, 15. I don't know why I hesitated so much. 15, divide both sides by 3, and I get x equals 5. Plus 9, 3x equals 3. Divide by 3, x equals 1. Remember, you write your solution smallest to biggest, so 1, comma 5. Last one. We're almost done. Okay, this one's a little weird, but not too bad. My absolute values alone. I'm going to rewrite it as x plus 7 equals the exact 2x minus 1. And then x plus 7 equals the opposite. So negative 2x was the opposite of negative 1 plus 1. So see how everything after this equal sign is opposite? What was positive is now negative. What was negative is now positive. And then I solve both. So I'm going to do minus x, and that gives me 7 equals x minus 1, plus 1, and I get x equals 8. Here I'm going to add 2x, and I get 3x plus 7 equals 1, minus 7, 3x equals negative 6, divide by 3, and I get x equals negative 2. And if you're ever unsure, can you check your work? Yes, you can. Okay, test is tomorrow. If you have questions, make sure you're asking.